Hello students, in continuation with our series on assertion and reasoning, today we'll take up alternating current. We have started with the first discussion on what are assertion and reasoning questions, what is the common mistake made by the students in solving assertion and reasoning questions, and what is the best way in which such questions should be attempted. After that, we have taken the different topics. We have started with electrostatics, followed by current electricity, then magnetic effect and magnetism, and after that we have taken electromagnetic induction. In that sequence, today we are taking alternating current. Let's continue our discussion on assertion and reasoning questions on alternating current. Now again, before we start, let's just see what are the different options given here. First option is the assertion and reason both true, and R is correct explanation of assertion. Assertion and reason both true, but reason is not the correct explanation of assertion. That is the second option. Third one is assertion is true, reason is false. And the fourth one, assertion and reason both false. So now let's see the different questions here. First one is, average value of current in half the cycle of an AC circuit cannot be 0. And reason is given for positive half cycle. Average value of the current is I0 by pi, where I0 is the peak value of the current. Now let's take the assertion part. Average value of current in half the cycle cannot be 0. Now here, when we take normal AC circuit there, in that case we may say that in this part it is not 0. Here also it will have some value. Okay? So half the cycle is not 0. That means you are taking in that particular way. But suppose if I have an AC here, and if I take from this point to this point, this is also half cycle. That means it is from this peak value to this one. This is also having half time period there, or half of the cycle. But in this one, if you consider the average value, in that case this will be 0. So when we say half the cycle, it is not mentioned from where to where we are taking that. Normally we take just either maybe from 0 to t by 2 and then t by 2 to t, like that. But we may take it from t by 4 to 3t by 4. In that particular case, it will be 0. Assertion, if you take, this is false. And now let's take the reason. For positive half cycle, average value of the current is I0 by pi, where I0 is the peak value of the current. Now, this is not correct, because the average value, if you consider for half cycle, that will be your 2I0 by pi. So in that case, this is also false. So here assertion and reason both are false. So that means the fourth one is the correct option. Next question. When the capacitor is connected to an AC source, it limits or regulates the current, but does not completely prevents the flow of charge. You have a capacitor connected to an AC. It will limit or regulate the current, but does not completely prevents the flow of the charge. This is true, because it will be offering some resistance there, and due to which there will be a flow of the charge which will be opposed there, but it will not prevent the flow of the charge there completely. And if you take the reason part, that the capacitor is alternately charged and discharged as the current reverses each half cycle. So this is also true. If you take alternating current, it will be changing its magnitude and direction periodically with time there. So for half of the cycle, it is going in one direction. For next half, it is flowing in another direction. So in one half, suppose it is charging it, in next half, it will be the discharging will take place there. Here, assertion and reason both are true. So what is the correct option for this one? First or second? When the capacitor is connected to an AC source, it limits or regulates the current, but does not completely prevent the flow of charge, because the capacitor is alternately charged and discharged as the current reverses each half cycle. So in this one, it is explaining it properly that how it can regulate the current there, and why it is saying that it does not completely prevents the flow, because we have seen that it is getting charged and discharged for half of the cycle there alternatively. So that means the first one is the correct option. Let's take the next question. Resonance phenomena is exhibited by a circuit only if both L and C are present in the circuit. So when inductor and capacitor both will be present, only in that particular case we can get the resonance condition there. So here, because the voltage across inductor and capacitor will cancel out one another, and then it will be only the ohmic resistance which is left there in the circuit. So current and the voltage will be in the same phase and will get the minimum impedance and maximum current there. So that means it is true. Now, reason part, voltage across L and C does not cancel each other, and the current amplitude is V0 by R. The total voltage appearing across R causes resonance. Everything is correct, but only this statement part, that voltage across L and C does not cancel out each other. They cancel out each other. That is why you have the voltage there and current in same phase. So in that case, this is false. So here assertion is true, reason is false. So that means the third option is the correct one. Let's take the next question. When capacitive reactance is smaller than the inductive reactance in LCR series circuit, EMF leads voltage. So here we have your VL and VC. Now if VL is greater than VC, because it is said that if it is this case, that means reactance term, if I take, it is IXL greater than IXC. So inductive reactance and capacitive reactance relation, if you consider, capacitive reactance is less than inductive reactance. And if it is such, in that case, the voltage term, if I take, it is your VL minus VC, and this is your V. So obviously the voltage or the EMF will be leading current there. So in that case, this is true. And the reason part, the phase angle is the angle between the alternating EMF and alternating current in the circuit. This is also correct. But now let's just see the two statements together. When capacitive reactance is smaller than the inductive reactance in LCR series circuit, the EMF leads current, because the phase angle is the angle between the alternating EMF and alternating current in the circuit. Now this is not making sense there to explain the assertion part, although both are true. So here assertion and reason both are true, but reason is not the correct explanation for the assertion. So the second one will be the correct option. Let's take next question. We use thick wire in the secondary coil of a step-down transformer to reduce the production of heat. Now, if you are using thick wire, in that case, what will happen? If it is a thick wire, obviously the resistance will be less. Remember, if it is your step-down transformer, the voltage there in the output will be less than that in the input. If voltage is less, since you have in ideal case, if we consider that input power and output power both are equal, so as the voltage is less, current will be more. So heat produced will be more. So if you are using thick wire there, so the resistance will be less. So the energy loss or the heat produced will be less. So that means this is true. And now let's take the reason part. So reason is when the plane of the armature coil is parallel to the line of force of magnetic field, the magnitude of the induced EMF is maximum. Now, this is true because if the plane is parallel, in that case, what will happen? The vector area will be perpendicular to that, and magnetic field, if you consider, the angle between the two will be 90 there. And if it is 90, in that case, the EMF will be maximum. That means this is also true. Now, let's just see the assertion and reason together. We use thick wires in the secondary coil of a step-down transformer to reduce the production of heat because when the plane of the armature coil is parallel to the line of force of magnetic field, the magnitude of the induced EMF is maximum. Now, this is not explaining how the use of the thick wire in the secondary coil will produce lesser amount of heat. So, assertion and reason both are true, but the reason is not explaining the assertion there. So, the second one will be the correct option. Let's take next question. An alternating current of frequency 50 Hz becomes 0 100 times in 1 second. If you take an AC there, if suppose I take this one, here, if you consider in one particular time period, it has 0 value twice. So here it is 0, this is also 0, and again it is the next cycle which will start. So that means here, if you consider that its frequency is 50 Hertz, that means the time period will be 1 by 50. So obviously in that particular case, as in each cycle, it will be becoming 0 there twice. So if 50 Hertz is the frequency, so it will become 100 times 0 in 1 second. That means this is true. And let's take now the reason part. Alternating current changes direction and becomes 0 twice in 1 cycle. That is what we have just discussed it also. So that means this is also true. So now let's take the assertion and reason together that an alternating current of frequency 50 Hz becomes 0 100 times in 1 second because alternating current changes direction and becomes 0 twice in a cycle. So it is explaining it properly why it should be 100 times in 1 second. So that means this first one is the correct option. Let's take the next question. A bulb connected in series with a solenoid is connected to an AC source. If a soft iron core is introduced in the solenoid, the bulb will glow brighter. Now, if you consider that the bulb is connected with a solenoid, you have a bulb here, and this bulb, suppose it is connected to a solenoid. Okay, this is your bulb. So that means if I assume that its resistance is R and this one has the value of reactance as X, so the impedance will be root over R square plus X square. When you are introducing a soft iron core inside the solenoid, so obviously its reactance term will increase. So if X will increase, in that case Z will also increase. And if the Z is increasing, in that case, if you have connected that one there to a source, in that case, what will happen? The current will decrease. And if the current is decreasing, in that case, the bulb will glow with less brightness. So that means this is your false. And here, if you consider the reason part, on introducing soft iron core in the solenoid, the inductance decreases. Now, this is also false. It's in inductance will increase. So, if you consider its inductance, it is increasing there. So, that means this part will be also false. So, obviously, here both are false. So, the fourth one is the correct option. Let's take next question. At resonance, LCR series circuit has maximum current. So this is true because at resonance, the impedance is minimum in series LCR circuit. So obviously the current will have the maximum value there. And the reason is given at resonance in LCR series circuit, the current and EMF are in phase with each other. So here, this is also true. At resonance, current and voltage are in same phase there in series LCR circuit. Let's now take the two statements together. At resonance, LCR series circuit has maximum current because at resonance in LCR series circuit, the current and voltage or the current and EMF are in phase with each other. Now, this is not explaining why the current should be maximum there. So here, both are true, but reason is not the correct explanation for assertion. So that means it is the second one, which is correct one. Let's take the next question. The possibility of an electric bulb fusing is higher at the time of switching on and off. Now this is true because what happens basically when you switch it on and switch it off, there will be sudden change there and the value of the current will change very rapidly there. So in that particular case, the bulb getting fused will be maximum there. So that means this is true. And inductive effect produces a surge at the time of switch off and switch on. So this is basically also a correct statement. And now let's take the two statements together. The possibility of an electric bulb fusing is higher at the time of switching on and off because inductive effect produces a surge at the time of switch off and switch on. This is explaining it properly and correctly that why there is more possibility of bulb getting fused at the time of switch on and switch off. So that means the first one is the correct option. Let's take the last question. 200 volt AC is more dangerous than 200 volt DC. This is true. AC is more dangerous than DC because of its peak value will be more there, and moreover the fluctuation of the voltage will be much higher there. So that means this is true. And now for the reason part, for 200 volt AC, the corresponding peak value is 200 root 2. But for 200 volt DC, peak value is 200 volt only. This is also true. Now let's just see that the two statements together. 200 volt AC is more dangerous than 200 volt DC because for 200 volt AC, the corresponding peak value is 200 root 2, and for 200 volt DC, peak value is 200 volt only. So obviously this is explaining it properly why it is more dangerous, because the peak value is 200 root 2. So in one case it will be 200 plus, and next half it will be minus 200 root 2. It means the voltage fluctuation will be of 400 root 2 value. So obviously this will be more dangerous. Not only just the peak value, but the voltage fluctuation which is happening is double. So that is why it is more dangerous. So the first one is the correct option. So this was our discussion of assertion and reasoning questions on alternating current. In next discussion, we'll take up optics.